we're just finishing up now, and let's do a little warm-up. But this is the lesson for mixed sine and cosine problems, so just mixing them in together, trying to decide whether you use the sine rule or the cosine rule, and different kind of applications. So let's do a warm-up first. Probably a good idea. So in this question, first of all, you're asked to find the length of x. Whereas x, I just kind of unhighlighted it, but it's already on yours. So we've got x, and you've got to decide, is it sine rule or cosine rule? So let's see, what have we got here? We're dealing with three sides and an angle. So try to think, three sides and an angle. What does that mean? Three sides and an angle. Hopefully if you've remembered, it means cosine rule. Remember, sine rule means angle, opposite side, angle, opposite side. But if you're dealing with three sides and an angle, we use the cosine rule. And we're asked to find a length, so we need to use the cosine rule for a length. So you can look in your formula booklet and you can kind of check it out. And if you've forgotten what the cosine rule looks like in your formula booklet, just look on the page on, I think it's page 2 of your notes booklet. There are the formulas that you're given: sine rule and the cosine rule and the area formula. So this is a cosine rule for the length, but remember, to find the length you've got to square root both sides. So what I tend to do is I tend to go straight to saying that the length, I've said a, like you can call it a if you want, because basically I'm just pointing out that a has to be the side opposite the angle. You could call it x equals, do your big square root sign first, is what I tend to do. And then remember, it's b squared plus c squared, doesn't matter which order you put those two, so long as a is the side opposite the angle. Minus 2bc, so use brackets to show that substitution, and then cos of 62 degrees. The great thing is that it goes straight into the calculator. The most common error is that people will forget to do the square root. They'll just work out what a squared is and forget that they should be square rooting both sides. So feel free to pause, plug it into the calculator to practice doing that, and then round to 3 sig figs. So 3 sig figs, you'll get 11.5 centimeters. Again, a good idea to write the unrounded answers in your tests and topic assignments, and then round to 3 sig figs, in case you make an error with your rounding. That one's done. We found the length x. Next one, find the value of theta. And I don't know why I erased it, but there it is, theta there. And we also need to expose this one, and you're given 8 over here. So again, have a look what you've been given. So you've been given three sides and an angle. So three sides and an angle, is that sine rule or cosine rule? Have a think, first of all, and I can probably confirm for you. Three sides and an angle means a cosine rule. Sine rule is side opposite angle, side opposite angle, side opposite angle. And the good thing is that, remember, the thing that's most important, these are b and c, but a has to be the side that's opposite the angle. So in the formula, a is the side opposite the angle. Try to remember how you write out the rearranged formula. A is cos minus 1 for the rearranged cosine rule. In the brackets, you'll have on the numerator b squared plus c squared. And remember, you minus the a squared. A has to be the side opposite the angle. So minus a squared. And just remembering that on the denominator, you've got 2bc on the bottom. And that goes straight into the calculator. Use the trig button on the TI Inspired to activate cos minus 1. Use a nice fraction button to make a nice fraction. And then you won't get errors due to BEDMAS. So you don't need to work those two out. In the old days, we didn't have those nice fraction buttons. So in the old days, we had to kind of work out this number and then that number first, and then put it into the calculator. But now you can put this into the calculator beautifully because you've got the nice buttons that create fractions for you. Try plugging it in. You get a weird answer because I just made up this question, and unfortunately, try to think, why is 180 degrees weird? Weird answer, because we're asked, what is this? What is this angle here? So if it's a triangle, is it possible to get 180 degrees? No, it's not. I just made up a weird triangle that doesn't kind of make sense. So not possible that that angle is 180 degrees, because 180 degrees is a straight line. And also angles in triangles add up to 180 degrees. So sorry, that was just a weird question I made up, but that's how you would calculate it. Question 3, find the angle theta. Angle theta, let's see, it's down here. And we've got that side, we've got this angle, and we've got this side. So we've got angle, opposite side, angle, opposite side. Is it sine or cosine rule? So two angles and their opposite sides means sine rule, as you can see. So two angles and opposite sides means sine rule. And just sine rule for an angle. So remember, here's the sine rule. So I would suggest use the flipped version. Sine A over A equals sine B over B. It's always easier, I personally find anyway, to put the thing you're looking for on the top. Just easy to rearrange. So we've got sine theta over 7. Has to be the opposite of each other. Sine theta over 7 equals sine 81 over 18. So let's just write that out to get our nice little method mark before we start to rearrange. In case we make an error in rearranging, we'll still get a nice method mark now. Sine theta equals 7 over 7 equals sine 81 over 18. To rearrange now, we need to multiply both sides by 7. And I'm running out of space here, so I'm just going to go straight to also on top of that, taking the sine minus 1 of that. So let's scroll down a bit. So sine minus 1 of 7 times sine 81, which we write as 7 sine 81, not sine 81 times 7, because that looks a bit confusing. 7 sine 81 over 18. Because you see this, I've just multiplied both sides by 7, and I've taken the inverse sine of both sides. Run it in the calculator and see what you get to 3 sig figs. 22.6, is it an angle? Is it a length? It's an angle, so you should have degrees. And now let's move on to the lesson where we're just doing a whole heap of practice questions. So mixed sine and cosine problems. So trick thing is, which one do you use? Do you use a cosine rule? Do you use a sine rule? So remembering, like in the warm-up, you use a sine rule when we're dealing with two angles and they're two opposite sides. So two angles and two opposite sides means sine rule. You use the cosine rule when you're dealing with three sides and one angle, is when you'll use a cosine rule. And in the diagram below, I kind of demonstrate that. So this one here, this diagram, I've got, let's see, remember you've got to circle the unknown when you're working it out. I've got three sides and an angle. What rule should we use? Just think about it for a second. And if you thought cosine rule, you were correct. In this example, we've got side, opposite angle, because remember we're circling the unknown here as well. Try to think what rule would we use, and you're probably correct. It's a sine rule. So just reminding you as well, this is the version given in the formula booklet, this one and this one here. You can flip this one easily to make it for an angle. This one you have to do the rearranging yourself to make it for an angle. So a equals cos minus 1, b squared plus c squared minus a squared, and a has to be the side that's opposite the angle over 2bc. Let's go on to some practice problems. And this page, like just a little poster I found on the internet, feel free to look at it. If it illuminates anything for you, that's great. Let's move on to the practice problems. So a triangle we haven't drawn for you has side lengths 11, 13, and 14 centimeters. What is the size of the smallest angle in the triangle? So a little trick is the smallest angle must be opposite the smallest side. So we might want to write that. Smallest angle must be opposite the smallest side, which I'll demonstrate for you by kind of doing a rough sketch of it. So we've got a side 11, 14, and then what's the other side again? It's 13. So 11, 14, 13. So I just kind of drew it in an exaggerated way just so you can point out the shortest side, the longest side, and the kind of middle length side. So because I've drawn it so exaggerated, it kind of helps you to see the smallest angle would be this tiny little angle over here. That's a big obtuse angle. That's an acute angle, but it's clearly bigger than this angle. So a clue is smallest angle must be opposite the smaller side. Now what are we dealing with here? We've got an angle, because remember you've got to include the unknown. We've got three sides and an angle. So what rule are we going to use? Have a think. And yes, it's the cosine rule. Fabulous. And remember, in the cosine rule for an angle, the A side, the letter A has to be the side that's opposite the angle. So A must be 11, and these two can be B and C. So let's use the rearranged version. Theta equals cos minus 1. Always good to do that first. Set up your fraction. B squared plus C squared. Doesn't matter the order, you can do 13 squared plus 14 squared, 14 squared plus 13 squared, but the a has to be opposite the angle. Minus 11 squared, and remember 2bc is on the bottom. So 2bc, 2 brackets, 14, 13. So please don't use a multiply sign, please use brackets for substitution, it's a lot better. As I've been going on about, I would strongly suggest write the unrounded answer first and then round to 3 sig figs. It's always safer. What units? It's an angle, so degrees. Cool, so moving right along. A and B are two towns, here's A and B, on either side of a pine forest. To get from A to B, by car, you need to turn off the main road at T and then drive to B. So from A to B, they actually are talking about go to T and then turn off to go to B. That's what they're talking about there. The turn-off point is 43 kilometers. So 43 kilometers. So let's see, hang on, what am I saying? The turn-off point is 43 kilometers from A. Turn-off point is here, and it's 43 kilometers from A, so we can mark that in. And 61 kilometers from B. So the turn-off point is 61 kilometers from B. So let's mark in 61 there. A to B is 116, and remember that symbol means angle. So, and the angle is where the middle letter is. So this angle at T is 116 degrees. So let's mark that in now too. Find the distance by helicopter of flying directly from A to B. So directly from A to B, instead of driving by car this way, if you flew by helicopter, you would be going this length here. So let's draw in that blue line and label it X because that's what you want to calculate. And you've got to decide, is it sine or cosine rule you're going to use to calculate this length X? So what are we dealing with here? We're dealing with 3 sides and an angle. Remember, you need to include the unknown when working that out. So 3 sides and an angle. Is that the sine rule or cosine rule? You're right, 3 sides and an angle. It is the cosine rule. Lovely. So it's cosine rule for a length, more specifically. If that helps, write that out too. So cosine rule for a length is simple. We could just use this formula, but we can go straight to square rooting both sides. I strongly suggest, because otherwise people forget that. So you can call it A. Oh, actually, well, I wrote out the cosine rule. No biggie. If you want to do that, you can. Don't have to, though. You can go straight to the substituted version, which I normally do. You've probably noticed. So A is the side opposite the angle. You could just call it X if you want. You don't have to call it A. Like I labelled it X. So A is 43 squared plus 61 squared. I should probably have called it X. Minus 2BC because of the angle. Angle has to be opposite the side that you're looking for. Throw it in a calculator just like that. Use your brackets for multiply. And hopefully you get something like this, unrounded. Good to write your unrounded answer first and then round to 3 sig figs. Unless it states otherwise. But it didn't state otherwise, so we did 3 sig figs. Fabulous. 88.7 kilometers is that length there. So we've found what we're looking for. Right, next one. Another word problem. The shortest distance from TT, this is golf course obviously, from TT to the flag F down here on a golf hole is 318 meters, so that's been put in for you. What else? Sharon drives a ball to her left to point X. So she obviously it's from the T. So from the T, she drives a ball to the left and towards X, and that's where it lands on the fairway. Given that X is 93 meters from the flag, which is already on there, 93 meters from the flag is here, and angle XFT, because it's got that little hat on it, XFT is 39 degrees. So XFT is 39 degrees, that's already on there for you. Find the angle theta that Sharon's drive was offline. And to help you, they've already drawn that angle in there. So basically, she was meant to be aiming for this, but she hit here. They want to know what angle did she miss by. So we want to work out that little theta. So that's a bit tricky. So we've got to work out something first. And a little clue is try to understand what we've got to work out first. What are we dealing with here? We've got a length. We've got a length. and we have an angle. But we're not really able to use anything to get theta immediately yet because we don't have enough information. So we need to be able to at least use an angle opposite side, angle opposite side, angle opposite side, but we don't have that. So maybe I will potentially want to maybe use this. You could use the sine and cosine rule eventually, but you might want to do this first. Maybe work out this length first. So I've labeled this length here x, because if we work out x using the cosine rule, because if we think of this as x, then we've got three sides and an angle. We can work out x using the cosine rule, and then we can use that to work out theta using the sine rule. So this is a bit tricky because you had to work out something, decide to work out something first before you use something else. Because then if you know x, then you've got side opposite angle, side opposite angle. Sorry, side opposite angle, side opposite angle. And then you can use that to work out theta. So a bit tough. Work out x first using the cosine rule because three sides and an angle. Cosine rule for a length is easy. You just go straight to the big long square root. B squared plus c squared has to be these two because x has to be opposite the angle. So now substitute all of that in. Cos of 39, because it's a side opposite the angle, is x. And you get this number unrounded. So I've written it all out unrounded, which is a good habit to be into, because this isn't the final answer. So you shouldn't be rounding your answers now. You only round when you get to the final answer. So use the unrounded answer for x. So we now know this length, we know this angle, we know this length, so we can work out that angle using the sine rule. So let's write a little plan for that. So this is a harder problem, obviously. Now use your answer, this answer that we just worked out, and the sine rule to find theta. So remember, we're going to use a version of the sine rule. We're going to flip this version of the sine rule because we're finding an angle. So do sine theta over 93 equals sine 39 over your answer for x. So to help, I also drew it out again, just in case you're not sure where I'm on about. So if you draw it out, like see, we've got side opposite angle, and we're going to find theta. So sine theta over its opposite side, 93, equals sine 39 over the unrounded answer for x. So definitely use your unrounded answer, like write out to lots of decimal places is the safest thing you can do. Equals, plug it into a calculator, what do you get? I end up, actually no, sorry, you have to rearrange it first. So to rearrange it, you need to multiply both sides by 93, and don't forget to also take the sine -1 of that answer. So multiply this blue fraction by 93, because we're multiplying both sides by 93, and then take the sine of -1. You can plug it in the calculator, use the trig button to make sine -1, use the fraction button to make this, and put this in with as many decimal places as you can. And when you do, because now you've got the final answer, you can round it to 3 sig figs, and I got 13.4 degrees. Oops, and I put a little thing there that I shouldn't have. So Andy is a surveyor who measures the exact dimensions of property boundaries. That's what he does for his living, to earn a living. Andy normally uses a laser measuring device, but today he cannot because a large number of trees block his vision, these trees here. Instead, he measures the distance from point A to the corner of the shed, C, to be 124. So he's just pointing out that A to C is 124. He measures angle ACB, so it's got to be here because the middle letter is C, to be 130, so that's that angle there. And the distance CB to be 105. How can Andy use his measurements to find the length of the boundary AB? So AB is here, so obviously that's going to be our X. So I've kind of given it away here though, but have a look, we're dealing with 3 sides and an angle. 3 lengths and an angle means cosine rule. And is it for a length or an angle? No, it's for a length, that's easy. Just use this version and square root both sides. Here we go. So X is equal to big square root. The 2 sides, that squared plus that squared, or B squared plus C squared, minus 2BC, same thing again. Cos of the angle that's opposite X is 130. plug that in the calculator just like that. Don't use multiply signs, use brackets for multiply. And when you round it to 3 sig figs, you should hopefully get 208 meters. That's what I got anyway. Let's keep going. The angle of elevation to the top of a mountain, and the angle of elevation is measured relative to the horizontal, are measured from two beacons, A and B. So two different angles of elevation. From B it's 41.2, from A it's 29.7. And they're at C. These angles are shown on the diagram. If the beacons are 1,473 meters apart, meaning this length here in red, so these two beacons are 1,473 meters apart, how high is the mountain? So they want us to work out this height. So you can call it H for height. I called it Y for some reason. Yeah, so different ways, lots of different ways you can do it. You can use all sorts of things, but in my particular case, I decided, okay, we want to work out this length here. I'm going to need to work out this length here. That's why I called this one X, because let's see, we know a length, we know an angle, and we can work out this angle here by using this big right angle triangle. So this big right angle triangle, we know that there has to be 90. So let's see. So it might help if I draw it out. Shh. Okay, so let's draw out the triangle. Here you go. So we've got a triangle. I've drawn it out here. So the triangle that we're going to use to begin with is to calculate X. We're going to use this triangle here. And we can work out what some other angles are. So this triangle here is the one I've just drawn out, because that's the one that I seem to have the most information about for now. So we know this length here is 1,473. We know this angle here is 29.7. How did I work out, try to think, how did I work out 138 is the angle here? So that angle there, how do you think I worked it out? And you probably guessed that I did, this whole angle here is 180, it's a straight angle. So to work out this green angle, I did 180 minus 41.2. And that's what I by accident was just erasing there. So 180 minus 41.2 gives us that green angle, which I put in here, 138.8. And if you want to, we could also potentially work out this angle, because we know two angles in the triangle. And remember, angles in a triangle add up to 180 degrees. So if you wanted to, you could also work out that angle. So 180 minus these two angles, what does it equal? 11.5 degrees. So you've kind of got three angles going on that you could potentially use. And notice I've just labeled A and B on there. So yes, why am I bothering to work out X first, you might be wondering. Well, if I know X, I can just use, and I can use the fact that this is a right angle triangle. And I can just use, once I've got X and I know that angle, I can use SOHCAHTOA to find Y. Because I'll have the hypotenuse, I want to find the opposite, and we've got the angle. So we can just use SOHCAHTOA with sine to find that. Lots of different ways you can approach it, as I said, but this is just one of the ways I found, because I saw the right angle triangle straight away, but realized I had to get X to do it. So to work out X, try to think what rule could we possibly use. We're not dealing with three sides, like we're dealing with two sides, so try to see if you can use the cosine rule. So you're going to do, let's see, you've got opposite angle and side and opposite angle, and you've got side and opposite angle. So this is a side opposite angle, side opposite angle. So we're actually not even going to use a 29.7. But it was part of the question, so that helped us to work out the other two angles. So let's use the sine rule to find X first. So sine rule to find X first. Let's go. So X over sine 138. X over sine 138 equals, because we're doing it to find a length, so use the length version, X over sine 138 equals 1473 over sine 11.5. There you go, that's our nice little method mark for using the sine rule. Now you're going to rearrange it. So all you need to do to get X by itself is multiply both sides by sine 138. So let's do that. X equals 143 sine 138 So this is a nice way to write it. If you wrote sine 138, 143, it's a bit confusing because it looks like you're multiplying 138 by 143. And because we did 1473 times sine 138.8, and then that's going to give you your x. So if you plug that into a calculator, we're going to get this. And remember, this is the unrounded answer because we shouldn't be rounding at this point, because we're just using x in order to get y. It's when we get y that is have our final answer, and then we round that to 3 sig figs. So don't round this to 3 sig figs. Write it out to as many decimal places as you can. It's a good idea. Alternatively, you can also leave it like that, but I find that a bit easier to work out the actual number. So we found out what x is using this sine rule. Now we've got x. It's kind of easy. We can just use a big right angle triangle. We know what this little angle in the corner is. We know that y is its opposite side and x is the hypotenuse, which we know the number of. So we can just use SOHCAHTOA. So let's draw the triangle, maybe that helps. Oops. Notice that looks like I wrote 129.7, but no, I just put in the little angle here, the little angle curve, and it's 29.7 according to the diagram. Degrees. We've got our length y that we want to find, which is the height, and x is what we found over here. So now we're going to use SOHCAHTOA. So let's put a little instruction so we look back and we understand what we're doing. Now use SOHCAHTOA to find y. Okay, use SOHCAHTOA to find y. So sine theta, I'm going to use so because we've got opposite and hypotenuse. Sine theta equals opposite over hypotenuse. It's just back to like lesson 2 or 3, I think it was lesson 2 of this unit. Sine 29.7, because we've got the angle, equals y over this number here. So y over this long number. Remember, we have to use the unrounded answer for that number, for the hypotenuse, so we don't get a rounding error. And then to rearrange this, how do we get y by itself? We get y by multiplying both sides by 4,866 point blah blah. So multiply both sides by that. And that's how you show that, because when you multiply this side by 48,066, and so sorry, 4,866, then when you multiply this whole term by that, it cancels out this number. And then to multiply, don't do sine 29.7 times this number, because then by accident people think you're multiplying 29.7 by that. But this whole thing is one bound unit. So you need to do that multiplied, this number multiplied by that. So put the number in front of it is the easiest way. Then plug it into a calculator. So you should hopefully get this is your unrounded answer. And then what have we been asked to do in our question? Have they said to round to anything like that? No, so it didn't say anything in particular, so 3 sig figs. So try to think, 3 sig figs. Why is this 0 not significant? It's because it's trailing, but not also after the decimal point. For it to be significant, it would have to be trailing and after the decimal point. So 2,410 meters. Here we go. Another example. Looks a little bit complicated, doesn't it? So xy, where's xy? Xy is this horizontal line here, xy. And rs, which one's rs? Rs is this kind of diagonal line. So x, y, and rs are both roads that intersect at point C. So obviously x, y, and rs, they intersect at this point C. That's an angle of 77 degrees. So what do they mean? They just mean this angle here is 77 degrees. There is an explosion at a factory D, so something goes boom over here. Which is a point D on CS. So CS. So see, RS is that whole thing. CS is just this little point here. So there's a big explosion at point D, at exactly this point. People observing at A, which is right here, and B, which is right here. B is right there, if you're not sure. So people observing at point A, just do that, and point B, note that angle CAD and angle CBD are 28 and 38 respectively, which is already written in here. So as you can see, CAD, so that's that angle here, is 28, and CBD is this angle here, which is 38. That's already on there anyway. It's always still good to read through it, because sometimes in the question they might have put a few things on the diagram, but maybe they didn't put everything. So it is worth reading over and seeing, can we write any extra numbers on here? A and B are 32.8 kilometers apart. That's already written in there. Find theta. So where is theta? Here's theta. So I've just kind of drawn the little angle in there. Theta. So that's what we need to do for part A. Then find the distance BD, that thing there. And then how far is D from the intersection C? That length there. So you're probably guessing we might do a bit of non-right angle trig. Yeah, pretty much. Radio. So find theta. Might have seemed that you had to do something complicated, but you can actually work out theta, because you know this angle here is 28. You can easily work out this angle here because it's just 180. This whole thing's a straight line. So 180 minus 38 would be this angle here. And so that angle, because it's a triangle, angles in a triangle add up to 180. So you can just do 180 minus 28 minus this angle to get theta. So it's just quite a simple thing, really. So let's try the working out for this angle first. So it's 180, I'm going to do that here. 180 minus 38 equals 142. So that means this little angle here we can mark in as being 142. And therefore, because 180 minus 38, obviously, it's a straight line, makes 142. We know this angle. These three angles have to add up to 180. So let's work it out. I might work it out down here now. Question A, theta equals 180 minus 28 minus 142, which is 10 degrees. So it turns out this little angle here, it's just 10 degrees. So I'm going to mark that in as well. Can be handy once you work something out, like a value or like a length or an angle, maybe mark it in on the diagram, because it might turn out to be really useful for B or C, but you might forget when you're doing B or C that you know this angle and think that you don't have enough information. So that little angle there is 10 degrees, and we've worked that out. Find the distance BD. So where is this here? BD. Okay, I've decided to call it X, obviously. So feel free to mark it in, call it X yourself. And let's see, what information do we have that could be useful? We know this length, and we know its opposite angle. And we want to find this length, and we know its opposite angle. So it's not cosine rule because we don't know we're not dealing with three lengths in an angle, but we do have side, opposite angle, side, opposite angle. So try to think, what rule can we use for that? We can use the sine rule. Lovely. So I always find it useful, just draw the diagram out again if you want, especially in your notes. It's helpful to, it's just very cluttered up here. So if you just draw the pure diagram that you need with all the information, sometimes it's a bit clearer when you look back on it to study. Otherwise it just looks like a big blob of numbers on a diagram. So I've just drawn out this triangle, this length here, 32.8. Here is its opposite angle, that's why I've highlighted them in blue. And 28 degrees here, it's not 128, I just drew in the little angle symbol, so 28 degrees. And opposite side is what we're trying to find, which is X. So I've written X in there and I've circled them in yellow to show side, opposite angle, side, opposite angle. Sine rule, it's for a length, so it's easy. Just put in this version. I'm going to use the length version, which we have already. X over sine 28, X over sine 28 equals 32.8 over sine 10. 32.8 over sine of 10. Lovely. And then just try to think, how do you solve for X? You would have to multiply both sides by sine 28. So now I'll show the step where you multiply both sides by sine 28. It's a good idea. You definitely need this to get your method mark, so definitely do that. I strongly suggest you show your rearranging, so if you do make any little boo-boos, examiners maybe will be sympathetic to you. So 32.8 multiplied by sine 28, we write like this. We don't write sine 28 times 32.8, because then it looks like the angle is these two things being multiplied. This thing is a bound unit. Plug it in the calculator, use your nice fraction button to do that. And to 3 sig figs, because we're quoting an answer, find the length BD. It's our final answer here. 88.7 kilometers is the length of BD. The last thing they want, how far is D from the intersection C? So how far is D from the intersection C? They want to know this length here. I might call that one Y. So now I'm going to label that one Y. Even better, let's just draw it out again down here. So we're going to draw out this. Try to decide. Hi, Shori. So try to decide which triangle you're going to use. I'm going to choose to use this one because I seem to have a lot of info here. And I'm guessing that the fact we worked out X might be useful for working out C. Let's start to draw our diagram. Let's label question C. So because we quoted the answer 88.7 to 3 sig figs, I'm going to use the rounded answer. But you could be even probably better is even to, depends on the examiner really, but even better maybe use the unrounded answer. But if you have quoted an answer here, you can kind of use it there, so long as it was a final answer previously. But to be on the safe side, feel free to use the unrounded answer if you want to be even better at working it out. And oh my, how did I get this angle 103 down here? So to begin with, like if you're looking at it, if you didn't know you had 103, you wouldn't have enough information to do sine or cosine rule. So I kind of end up working at 103 because I figured then I'll have side, opposite angle, and I'd use sine rule again. And I found it really easy to work out this angle because look at the diagram. You've got a 180-degree angle here, so it's just a simple calculation. We just do, for this little angle here, 180 minus 77 will give us this angle, 103. So 180 minus 77 gives us a 103. Those two add to 180, lovely. So we've got side, opposite angle, because we want to find y. So what rule is it again? Is it sine or cosine rule? It's the sine rule again. For non-right angled trig, we have to use sine rule or cosine rule. So it's for a length, so I'm just going to use the same version. Y over sine 38 equals 88.7 over sine 103. 88.7 over sine of the angle. Get your method mark by doing that lovely. And to solve for y, you need to multiply both sides by sine 38. So how will we show the rearranged version? We could go 88.7 sine 38. Means no multiply sign, looks nice and sophisticated. Very clear working out step there. Plug it into the calculator using a fraction button, and you should hopefully get 56.0 kilometers. So if you're noticing that through any of these videos you're plugging it in the way I say, but you're not getting the same answer, maybe double check if your mode is in degrees. So for us, our mode needs to be in degrees and not radians, but the calculator default settings are radians. So to do it, remember, like, go to your document settings and see whether or not if you're not getting these answers, if you're getting other weirder answers. See, just check, is it in radians by mistake, and then change it to degrees and select make default, so it will always be in degrees. Okay, and you should hopefully went to 3 sig figs. I would again suggest write the unrounded answer first and then round to 3 sig figs. So then if you have made a mistake in rounding, the examiners might be sympathetic and give you the mark anyway. So y equals 56.0 kilometers is, just relate back to what we're doing, is what that length there is. And that looks like that's the end of the lesson. So unit finished. Well done.